In the Hindu mythology, we came up with this deity called Surya Devta, the sun god. And it's not only Hindu mythology. You see, you go to any other form of any other culture or any other civilization, and you wouldn't find like direct relationship with gods like maybe Ganesha or maybe Lakshmi, because these gods have come from the needs of people after they realized what they need in life. For example, Lakshmi is the god of wealth and money, right? And there are gods for wealth, but they're very different. Yeah, but sun is something which was there for everybody in the world, and so everybody was scared of the sun. Everybody wanted to worship the sun, and that's why every single civilization has got a deity for the sun. The Egyptians worshipped sun as Ra, the sun god. The Greeks worshipped sun as Helios or Apollo. Then you have the Mesopotamians, you have the Japanese. Every single civilization has had a sun god. And why not? I mean, obviously, sun gives us what crops, right? If you don't have sun, you won't have crops. If you don't have crops, you won't have food. And also, sun also takes away crops by famines. So it's the same sun that's giving you crops. It's the same sun that's taking away food from you. It's the same sun that gives you these things in the sky that people never understood back then. Like, in the medieval era or in the historical periods, that why are these things happening in the northern latitudes? Is that aurora? Yeah? And then again, when people were scared of these things, people also realized that in these northern latitudes, the only warmth that they could get was from the sun. And now that our needs are getting more and more refined and our needs are getting more and more, we're getting more and more demandful, we're sending satellites for communication, and satellites are directly affected by stuff that happens on the sun. In fact, there was a solar storm that destroyed 40 SpaceX satellites, which led to a $100 million loss. So a certain someone was very sad about it. Yes, it is true. It is true. Yeah, there was a huge loss. Some 40-50 satellites got destroyed because of a solar storm. Yeah, I think sometime in 2023. Yeah. So coming back, you see, this is the sun as we kind of see it, and there was this. You might think that these events are pretty rare and they don't happen much, and maybe these things are happening in the sky and it's not happening on Earth. It doesn't really affect us. But then again, on 10th May 2024, there was this huge sunspot that caused a big solar flare. Yeah, and that led to huge aurorae all over the northern part of the world. In fact, North America and all these places of Russia, even in Ladakh, to some extent, these aurorae were visible. Pardon? Yes, but these things generally happen at latitudes little further away from Antarctica. Yeah. Okay, so why don't we do this? Why don't you write down what you want to ask, and then when I'm done, we'll come back to the questions. Yeah. Okay. So there are these. So this huge aurora happened, and certain parts of Canada, the power grids failed because of this huge sunspot. And because the power grids failed, there was no electricity, and it was a huge chaos, right? And this is not the only thing. The largest one that has been recorded till now is called the Carrington effect. It was seen by Richard Carrington and Richard Hodgson, two scientists or two astronomers who were looking at the sun in 1859, and both of them independently kind of observed this. And what they saw was that on the sun, while they were observing, there was this sunspot, a dark patch on the sun, and then one small portion in that region, it kind of became bright suddenly. And around the same time, there were these conversations between telegraph operators that later got published, and people got to know that there were these telegraph lines which they had switched off the power at that time, but still the lines kept running. And people were very, like, these two telegraph operators, they were very surprised that how come the telegraph line can still be running when you have switched off the power. And then that was related to the Carrington event, because it was a huge solar storm that even kept the telegraph lines running, even when the power was turned off. Now, if such an event happens now, it's going to be a huge disaster because we have a lot of satellites. So the sun has a innate cycle of its activity. So the sun is not always the same. Every 11 years, the sun becomes more active, and then after a couple of years, the sun dies down, and then again it becomes more active. So you see, when you have a solar minimum, you don't have many sunspots, and the sun kind of looks, dull. And then when there is a solar maximum, you have a lot of sunspots, and the sun looks very, very bright. And there are lots of explosions happening on the sun. So if you look at this, you would see that the sunspots, they kind of increase, and then they decrease, and then they increase, and then they decrease, increase. Yeah, this keeps happening. But there was this one time around 1650 and 1700, a span of 50 years, when suddenly sunspots stopped. And it's exactly around that time there was this little ice age in Europe. Things became very, very cold. Yeah? And people didn't know why that was happening. Later kind of people, went back and saw the sunspot data and found out that probably this little ice age must have happened because of solar activity. And that's the thing, that's the kind of thing that we need to be careful about, because we don't know when this is going to happen again. Yeah? Or when sunspots are going to hit, when there is a solar storm coming. So we have kind of figured out why this sunspot cycle happens, why sunspots come and then they die down and then they come and they die down because of magnetic fields in the sun. Yeah? But there are many other things that we still don't know the reasons to. So we have kind of established that the sun is like the generator for the entire solar system. Right? Yeah? Sun creates power for the entire solar system, and also the sun is powerful because it's holding all the planets by its own gravity. Yeah? So that's the most important thing about the sun, that the sun is a powerhouse of the solar system, number one. Number two, the sun is gripping all the planets and making them go around the sun. So if we go into the sun, we would see that the sun is a core where the power is generated. Then there is the convection zone where it's kind of like, water boiling. Instead of water, it's just very hot plasma. Yeah? And then on top of that, you have the surface of the sun, that's called the photosphere. Then you have the sun's atmosphere, or the chromosphere, and outside that you have the corona of the sun. And exactly, if you are thinking coronavirus, the name of coronavirus came from this corona of the sun. Yeah, I'm not joking. That's true. Yeah. So, if you looked at the core is like some 15 million degrees Celsius. Yeah, 15 million. It's a lot of temperature, huge temperature. Yeah? And then you come to the convective zone, it's like 2 million degrees Celsius. And you come to the surface, it's like 5,000, 6,000 degrees Celsius. But then again, the funny thing happens, as you go out from the surface is 6,000, you go out to chromosphere, it's 4,000, it gets cooler. And then you have to go to upper chromosphere, it gets hotter, 10,000 degrees Celsius. And then you go to corona, it again becomes some 1 million degrees Celsius, and nobody knows why. So just imagine, there is a candle, okay? You touch the candle, you will feel hot. Yeah? And then you go a little bit away from the candle, you will feel a little cooler. You go a little bit away, you will feel a little more cool. What if you go further away and you start feeling hot again? Does that happen? It doesn't happen, no. So why is this happening in the sun? Nobody knows this. Everybody is coming up with new theories, new ideas, and nobody knows. And see, the sun is something that we have been seeing since since humans came 2 million years ago, we are looking at the sun for 2 million years. We have been studying the sun a couple of 100 years now, 400, 500 years. Nobody has been able to figure out why this is happening. In fact, we kind of discovered this around maybe 150 or 100 years ago, that the corona is hot. And nobody knows why. So, if you think what the corona looks like, if you have seen total solar eclipse photos, or if you have seen a total solar eclipse, this part of the sun is called the corona. When the moon blocks the view of the sun, then you can see the corona, because the corona is always visible, but it's not very bright. So the light from the sun, it kind of overseeds the brightness of the corona. So this is the corona on the outside of the sun, and then this red stuff over here, that's the chromosphere. So you see the chromosphere and the corona when there is a solar eclipse. But then scientists are mad, right? scientists want to do stuff that nature doesn't